That has to do my nursing stuff at Sagal's or Brookings.
Or in Rapid.
We'll figure it out. We'll make it happen.
Got it all planned.
Hopefully.
Well, we can always. That's one of the aspects. What is it? That's the only emotion more powerful than fear is hope. Something like that. I think. So yes, it's something to hold on to is certainly hope. Okay. So we can only hope that we know that carbohydrates deal with all the different types of sugars, whether we start with monosaccharides, and we've seen some examples of those. And again, in my mind, it's the disaccharides that are probably going to be the most difficult part of this. And it's just because it's how you link these together that we know that on that table, and we'll look at that here in a couple of minutes on page 536. Yes, it looks like it's fairly intimidating when you first look at it, but for instance, when you take two glucose molecules and hook them together, it could possibly be lactose or it could be maltose. And one of the well, I say the genes that we want you to be able to memorize, or that we want you to know, is glucose, mannose, and galactose. And we'll look at some of the ketose sugars in a little bit here, just a few moments as well. And that's probably the most common one for that is ribose, I believe. Okay, so moving on. When we're talking about carbohydrates, it's probably the most basic unit of nutrition where we get our energy from. So when we refer to sugars, yes, they're saccharides. If we're only talking about one at a time, then it would be a monosaccharide. Or if we're talking about, for instance, glucose and sucrose bonded together makes the disaccharide fructose. And then if we're talking about starch or cellulose, those then are repeating units of glucose molecules known as polysaccharides. So hopefully we are somewhat refreshed coming back from our extended weekend. Perhaps for some of you, it seemed like any time off. Here we are. Another couple weeks. Quarter 3 will be in the books. It'll be your last. We're about ready to wrap up your last third quarter, and we'll begin your last fourth quarter. At the beginning of the year, it would maybe just seem like the size of a golf ball at the end of the tunnel. Then semester exams were here, opened up the size of a basketball, and pretty soon I would say it looks like a beach ball. And then about 3 weeks, so be about ready to walk through.
I was real like, no, I'm ready. Well, literally, it hit me this week. I'm like, it's time. I'm ready.
So and when we get to the cellulose, we'll see why it is that plants are able to stand upright because of the way that those units are bonded together. And there's no reason to talk about that right now, other than just mentioning that cellulose is a polysaccharide, repeating, glucose molecules. That's what I'm trying to say. And one of the things I try to explain to all the classes is there's just so much information to go over. And at this level, where should that stop and what should we cover? Well, of course, we always say the basics. And to everyone's opinion, the basics is always going to be different. So that's why hopefully you all put your trust in us to pass this information on to yourselves. Okay, I had made a mistake. It's actually glucose and fructose is a disaccharide that makes sucrose. I had it somewhat backwards. But one of the things, keep in mind, why are we talking about paper? Really? That's a starch? Well, one of the things we always like to say as a joke is, let's say you go to one of your FCCLA conventions. Would you both go to that? And then they hand out a really thick binder of paper, and something you might not go over. What's the first thing? Well, I shouldn't say the first thing, but what do people mainly say as a joke with all of that paper? Killing trees. So, and if that's the common theme that people say, which it is, you're killing trees to do this. What's the link between trees and paper? Well, it's the pulp that comes from the trees, okay? And with some handy, or I should say, maybe even complex chemistry, it's one of those aspects we've all been there doing laundry. We take the clothes from the washer, put them in the dryer, and then maybe you fold them, hang them up. We're talking about some of your maybe blue jeans or dress pants that have pockets. And next time you put them on, you reach in your pocket. Oh, there's something in there.
Lint.
No, something better than lint. Money. Well, how is that possible? Shouldn't that have, you throw any type of other paper in there, it's wadded up and you can't tell what it is anymore. So why is it that money doesn't dissolve it? Well, yeah, it's the chemistry involved in that allows that to happen. But just think, something like that was probably, I don't know when that would have been invented, but just think how revolutionary that would be to think ahead to say, well, rather than having this money be destroyed, let's try to alter the composition of that paper so that doesn't happen. And obviously, thankfully, it's happened to me a few times, and usually when that does happen, that's kind of a pleasant surprise. Money that you forgot that you had. The only downside, oh, geez, it's only a one.
Right.
Instead of something with a one with a couple of zeros behind it. Right? Yeah. Yeah, we can all wish, but sometimes, yeah. Until you get out on your own, it's probably just going to be one. Even when you're working in a job for a few years, it's still only going to be one. Okay, let's see once more. Okay, so notice that we don't have a lot to go over, but this will be the last slide we go over for today. Polyhydroxyaldehyde, polyhydroxyketone. Okay, and I think that was on your vocab list from last chapter. And now just looking up at that, rather than looking at the word here, now when I see this, it makes more sense. It's a Fisher projection formula. We're talking about the lines and the railroad ties, or stitches. That's really what you're talking about with a polyhydroxyaldehyde and polyhydroxyketone. But one of the questions, and I think would be a good one to ask, is why is there glucose and fructose and sucrose and all these other different monosaccharides and disaccharides? And really, I really can't provide an answer for that if someone was to ask, other than we've said this before, it's the orientation of these OHs and how they're bonded and how they're linked is going to change its chemical properties, especially when it comes to starch. Again, we'll see that as an example probably in, I don't think we'll get into those for probably another couple of weeks or so, because again, the most difficult part of this in my mind and opinion would be that of the disaccharides. Okay, so just keep in mind that all we're doing right now is just looking at single glucose molecules, single fructose molecules, or anything to that extent. Those are just, I wouldn't say simple sugars. That's what they refer to, just because it's only one unit at a time. One glucose molecule bonded to another. Okay, so what we want to do, and notice when we look at this, I think it was Tom that had mentioned that, was it last week or 2 weeks ago, something about the first carbon, about is it show time? Is that what it was?
Yes.
Yes, that's what it was. I had to think about that for a moment. Okay, so when it's show time, one way to look at that is it's an aldose or aldehyde. Okay, and if it's a polyhydroxyketone, well then it's going to be a little different. And the reason those are different is just think back when you learned what an aldehyde was in a ketone. Both of them are carbonyl atoms, but the difference is where that oxygen's at. If it's an aldehyde, it's where? On the end. If it's a ketone, somewhere other than the end, in the middle, other than the end. Okay, so we'll continue with this information at a later time, but now for probably the next better part of 2 weeks, we're going to be working on drawing these structures. Okay, so remember, what we want you to do is make sure that when we look at this, we know that this is glucose. Okay, so this is a polyhydroxyaldehyde. Reason, what did it say up here? It said multiple OHs. And we know that this is an aldehyde because, one, it's CHO time. I sure hope he looks at this. So we won't say anything. We'll just see if he comes back and says anything about it's CHO time, it's CHO time, it's CHO time. See if he says, he said it 3 times in a row. But you can tell him, whichever. So this is an aldose sugar, which it is. Well, then if we see something like this, I think there's only 4. Oops, I did draw one too many. There's kind of a little more difficult with that of ketose sugars. It almost looks like it's a mirror image.
The athletic trainers here, if you'd like to see him, please go to the training room. The athletic trainers here.
Okay, that's what we mean by a mirror image. And yes, there is 6 carbons. And you might be thinking, well, if these were carbon atoms on an aldose sugar, how can this be 6 carbons on a ketose sugar? And that would be a very relevant question. It's like we see here and here and here are carbon atoms as well. But remember, if we're talking about a polyhydroxy ketone, that means there's a carbonyl carbon in there. And the definition of a ketone means there's a double bonded oxygen anywhere in there except on what? On the end. So what that means is, and this is how you would draw these, you just put a symbol like this, and then therefore we know that on that second carbon is a double bonded oxygen. So now we can see the structural difference between what we consider an aldose sugar on the left, or polyhydroxyaldehyde, and a ketose sugar on the right, or polyhydroxy ketone. And what can be a little easier to remember with these is if we're looking at left, right, right. So left, right, right. This is what we call fructose. Okay, and as you can see, fructose is still a 6-carbon sugar, but what's so tricky about it is it's only a 5-sided structure. That's what can get to be so tricky about this. But we're not going to spend a whole lot of time on this yet, okay? Just because we're not quite ready for that. We just want to introduce what the difference was between an aldose sugar and a ketose sugar. Okay. So, again, one of the things, I can't stress this enough, you need to know the difference between and memorize what the structure for glucose is. And I wouldn't memorize the 6-sided figure structure. Yes, you can do that. But if you can transfer that information from this, you're always going to have it right no matter which one you're talking about. Okay? So if glucose is right, left, right, right, which it is, something I was going to think about. I think mannose is left, left, right, right. Is that correct? Bingo! So then we know that galactose is right, left, left, right. Is that correct?
Right, left, left, right.
Okay. So, is there any, when you think about that, are you going to think, oh, how in the world am I going to keep them separate? Well, for all practical purposes, the more you draw these, the better you're going to get at it. And if you just center around glucose, going right, left, right, right, well then galactose is fairly similar, except for on carbon 4, it's not on the right, it's on the left. So galactose and glucose are fairly similar, where mannose is kind of a little different. It's left, left, right, right. Okay, so if that is the case, I don't know what would work best for you. So let's just go ahead and look at mannose then. And we always know that this guy's over here. Last one's always on the right. Okay? And mannose was left, left, right, right. Okay? And if you draw these hydrogens in, fine. If not, that's fine. Okay. All right. So the next thing that we want to do remember, is the author says, and they're right, you would take this and put it on its side. We're not quite ready to close the structure yet. And I think you'll get better at this as we practice it more and more. So the first step is we've got this way out here. Okay. So this was carbon 6 way down here. And we've got a hydrogen atom. This guy, because this is carbon 1. And then a double bond oxygen. So there's this guy. So then just go right around the ring here. So if it's on the left for carbon atom 2, where's that OH? Is it up or down? If it's left, is that up or down here? Are you sure? Yes, you are. Correct. Okay. So now we go over to this one. Okay. So the third carbon atom is on the left. So if the second one was up, well then the third one's going to be up. So then over here on number 4, it's down. Okay. And then number 5 is right, so it's down. And then this is where it gets to be kind of tricky. Okay. This OH wants to be on the end, so it flip-flops. Now, it's hard to visualize, but again, this is in 3 dimensions. So this would be step 1. And then in step 2, once we've flip-flopped those, now we've got that 5th OH, this one, way out here on the end. Everything else is still the same. That's still there. That's still there. So now, once these flip-flopped, this is up here on top. There's a hydrogen there. These are still the same. And again, you'll get better at this the more you practice it. It seems like it's a daunting task right now, and I would tend to agree that this probably seems a little difficult. But now, run the home stretch. We have to close it, and this is why learning the idea of what a hemiacetal was so important. Because what is so significant about this guy right here? He's going to leave. So now, what do we want to do with this mannose? Do we want to make it alpha D mannose or beta D mannose? We can. And maybe I should have given you a choice. The reason I say that is I see last week we did alpha D ultras. So maybe we should do beta D mannose. Okay? So beta D mannose. Okay? So now what that means is now we're going to close that ring. Which way do you like drawing 6-sided figures like we did with benzene, where you start like this instead, or do you like this here better? I like drawing it this way much better. It seemed to be a little easier, but what's nice about this is when we start talking about the monosaccharides, we know that we're in the spring. Maybe it doesn't quite feel like it, but the end is in sight. Okay, so go ahead and draw these lines in here. And which OHs can we safely move from? We'll say this is step 1, this is step 2, this is step 3. So from step 3 to step 4 now, which ones can we safely transfer over? Okay, so 2, yep. 3 and 4. And what about 5 here? Yep, we can continue with that. this is just where it gets to be a little tricky. That's why we put a box around it. Because what is that hydrogen, what we learned from last chapter when it comes to hemiacetals, when you have an aldehyde reacting with an alcohol, what does that hydrogen do to something down here? It breaks what? It does. But it doesn't break the oxygen. I know what you mean. Breaks the double bond. Okay? So the reason that's significant is if we're talking about beta D mannose instead of alpha, it's the orientation of where that OH is going to be. So once this leaves, there's just a single oxygen in there. Yes, you close the ring, but typically you should we should do this so we know that that's an oxygen atom there. So now, once this has gone down here to break that, is that OH pointing up or is that OH pointing down? Yeah, 50-50 chance.
Ooh, it's beta, and beta points up.
It does. So buckle up. Or buckle up. Okay? So if that's the case, which it is, so if this was alpha D mannose, well then this OH would be down here. Okay? Now, the reason that this is so important is because when we start linking these, I don't think quite this week, maybe next week, probably a little later, that when these start linking together, that's when you start making your disaccharides. And it makes such a difference where this guy's pointing and that guy right there, 1 and 4. Okay.
So I have a question.
Yes.
Beta, when you just put a beta or alpha in front, it's just showing you where the OH is pointing.
For carbon 1. Yes. Yep. So remember on your Fisher formula, it said R and D. So right meant down, which it does. So LU left up. I don't know how you, but as long as you just remember this one, well, and if right is down, well, then left has to be up, which I think everyone would agree. Then the next thing you have to be concerned about is that alpha or beta D mannose, which we said beta, so that's why this guy is pointing instead of down. All right, are we good? Okay, that's all I've got. We'll catch up with you next time.